Hi everybody, we have our first big test tomorrow, so I just wanted to go over a few things. If you look in modules, there's another document that has like some tips and tricks and some notes to look at in preparation for our tests. We also have the test review solutions that we went over today in class and some of those examples I did. And then we can also use this video. So when we look at something like number one, remember this exponent is going to be distributed to every single thing inside. Sorry about that. Everything inside of the parentheses in both the numerator and the denominator. So let's go ahead and rewrite this. We have 7 to the negative 2 power. X to the negative 3 times negative 2 is going to be positive 6. And then 2 and negative 2 is going to give me y to the negative 4th. And then the denominator, we're going to have 4 to the negative 2nd power. Y to the negative 4 times negative 2 is going to give me a positive 8. Now I like to deal with my negative exponent, so I'm going to identify what has a negative exponent and where it needs to move. I believe that this is the easiest way to go about doing this so we don't make any silly mistakes. So I'm going to go ahead and rewrite. My 4 goes to the numerator. X to the 6th stays in the numerator. And then in my denominator, I have 7 squared. Y to the 8th is going to stay there. And then we're going to bring down our y to the 4th. And now we simplify. 4 squared, everybody, is 16. X to the 6th over 7 squared is 49. And then I have y to the 8th times y to the 4th. So same basis, we're going to rewrite the base and add the exponents. 8 plus 4 is 12. Okay, moving on. Let's go to the next one. We're going to simplify. And I see here I have a 3 plus radical 5 in my denominator. That stays together, guys. So how do we get rid of this? Well, we're going to multiply by the conjugate. What's the opposite of 3 plus radical 5? It's going to be 3 minus radical 5. And what you do to the bottom, you do where? To the top. So 3 minus square root of 5 on the top. So I'm going to go ahead and FOIL the bottom just to make sure that my denominator, the radicals cancel. So 3 times 3 is 9. 3 times negative root 5 is minus 3 square root of 5. Positive square root of 5 times 3 is plus 3 square root of 5. And positive root 5 times negative root 5 is minus the square root of 25. So you'll notice here my positive and negative 3 root 5s cancel. The square root of 25 is 5. So I have 9 minus 5 is 4 in my denominator, which is exactly what we wanted to happen. We wanted our radicals to cancel out. So 9 minus 5 is 4. And then in the numerator, we're going to FOIL. 2 times 3 is 6. 2 times negative root 5 is minus 2 square root of 5. Negative root 3 times 3 is minus 3 root 3. And then I have negative root 3 and a negative root 5 gives me positive root 15. Now there is nothing here that has like terms, guys, so you cannot combine anything. So just rewrite 6 minus 2 square root of 5 minus 3 square root of 3 plus the square root of 15. All of the radicals are different, so you cannot combine them. If they were the same, then you could, but you cannot because they're all different. All right, again, we have something like this. You should always look to simplify first. I see that 17 goes into 34 2 times, so I can simplify that right off the bat. And I also see that I can break 33 into 3 times 11, and I can break 15 into 3 times 5. So now I can cancel out my 3's. So I'm left with the square root of 11 on top, and then 2 square root of 5 on the bottom. Now we still have an issue with a radical on the bottom in the denominator, so I need to rationalize. I'm going to multiply the numerator and the denominator by square root of 5. So 11 times 5 gives me the square root of 55 over 2 times the square root of 25. Some of you are like, well, that's just 5. Yes, it is. The square root of 25 is 5. So I have the square root of 55 over 2 times 5 is 10. And there's nothing else to simplify there. Radical 55 and 10 do not simplify. 55 is underneath the radical, 10 is not. So there is your simplified answer. Okay, now we're looking here, guys. Again, don't get yourself confused. Don't make things harder than need be. Take this exponent and go ahead and distribute to everything in this parenthesis. And let's simplify. So I have negative 6 to the second power. A to the 4 times 2 power to a power, we multiply, so 8. And then I have b squared. And then here I'm going to distribute my 3. So I have times negative 3 cubed. A to the 2 times 3 is 6. B to the 5 times 3 is 15. And now we simplify. Negative 6 squared is 36. Negative 3 cubed is times negative 27. Then I have A. I'm multiplying the same bases, so I'm going to add exponents. 8 plus 6 is 14. And again, I have B. Same bases, rewrite the base, and add the exponents. 15 plus 2 is 17. And then we multiply 36 times 27. Guys, if you have to write it down because you can't do it in your head, perfectly fine. Write it down and multiply. That would give you negative 972, a to the 14th, b to the 17th. All right, moving along, you have 36 to the negative 3 over 2. So think about this. This is 36 to the negative 3 over 2 over 1. Our first thing that needs to happen is this needs to come downstairs. We need to put a 1 over because you have that negative exponent. So I have 36 to the 3 halves. Now, when we write our rational or fractional exponents, your index is your denominator. Your denominator becomes the index. So this is 1 over the square root of 36 to the 3rd power. So this becomes 1 over square root of 36 is 6 cubed, and then 6 times 6 times 6 is 216. Again, if you don't know that, write it down. 6 times 6 is 36. 36 times 6, multiply it out. Okay, last 3. Again, all sorts of different factoring are going to happen, but what I need you guys to do is to take out the GCF first. Any factoring problem that we do from now on, guys, and we're going to see a lot of it. It's not going anywhere. You've got to take the GCF out first. Then it makes your problem easier. So the first thing I look at in A is I say, okay, is there a GCF? All right, 36, 121, x squared, y 4. No, there's nothing that I can take out of both of those. So then I'm going to say, okay, I have 2 terms, minus sign in the middle. Are these 2 perfect squares? Is this the difference of perfect squares? Well, what times what gives me 36x squared? It's going to be 6x and 6x. What times what is going to give me 121y to the 4th? 11y squared and 11y squared. If I have the difference of perfect squares, my 2 parentheses have the same terms, 6x in the front, 11y squared at the back, and different signs in the middle. So one is a plus and one is a minus. It doesn't matter where the plus goes, where the minus, just as long as you have one of each. And if you wanted to check, you could FOIL those back out and you would end up with what you started with. Okay, next one, I look and I say, okay, whoa, there's a lot going on here. Well, first thing I notice is that my highest exponent is not first. So I'm going to rewrite this as 27x to the 4th plus 21x cubed minus 15x squared. And we talked about this a lot the last few days. The first thing you take out is the GCF, guys. So do you see a letter and or a number that all 3 of these have in common? The answer is yes. I can take out a 3x squared from all of these. So I have 3x squared out in front. It doesn't disappear. We just write it in a different spot. So 27 divided by 3 is 9. X to the 4th divided by x squared is x squared. 21 divided by 3 is 7. So I have plus 7. X cubed divided by x squared is x. And then negative 15 divided by 3 is minus 5. And your x squareds cancel. And then you look to see, okay, I have a trinomial. Is this a perfect square trinomial? No. We haven't really done more extensive factoring, but we would say 9 times A times C, negative 45, factors of negative 45, that'll multiply to give us negative 45, add to give us 7. There isn't any, so you would just say this is simplified. Okay, and lastly, we come to something like letter C. So I think, okay, is there a GCF? No, there isn't. And then I think, oh my gosh, these are big numbers. I'm not really sure. Let me check to see if this is a perfect square trinomial. How do we check? Well, is the first term a perfect square? Yes, 11x and 11x, perfect. Is the last term positive in a perfect square? It is, 2 and 2. So how do I figure out if this is a perfect square trinomial? I take the first times the second, 11 times 2 is 22, and I multiply it by 2. Is that 44? Yes, it is. So I know that I have 2 parentheses that are exactly the same. 11x in the front, 2 at the back, and this sign right here goes in between both of them. So you can write your answer like that, or if you wanted to, you could write it as 11x minus 2 quantity squared. Another thing, guys, please remember, you will absolutely will have cubes. So think about if you have a cube, if you have a problem that's like, I don't know, 2x cubed minus 16y cubed. First thing we look for is a GCF. Is there a number and or letter that goes into both of these? Yes, 2. So I'm going to divide out that 2, and I'm left with x cubed minus 8y. So is this the difference of perfect squares? No. Is this the difference of perfect cubes? Well, what times what times what gives me x cubed? That would be x. What times what gives me 8y cubed? That would be 2y. So we have determined, yes, this is a perfect cube pattern. So my 2 is still out in front. My first parenthesis is going to be a minus b. My second parenthesis is going to be my a term squared plus a times b, so 2xy, and then I have plus my b term squared. Now look what I did here, guys. I put this b term in parentheses because this 2 goes here and here. So my final answer is 2 times x minus 2y times x squared plus 2xy plus 4y squared. And that would be your cube pattern. So make sure you guys know the perfect cube pattern. And if you have any last minute questions, you can come see me in the morning before 7:50.